Alright, so in this video I'm going to share with you how someone used this geometric pattern to come up with the design for the numeral that represents the number 4. So they used the fourth circle in this series of circles. So that's the circle that has the radius of the square root of 4, which is 2. They use one of the points that defines that circle. So there's 4 points that define the position of that circle. We're going to use these two here, that one and that one. And we're just going to draw a line straight down, connecting those two. So we have a line that's the length of 4. So that's a property that all the numerals have. They all contain the value of the number that they represent as a length within their design. You can see I've highlighted some other points that are formed by this internal pattern. I'm just going to connect these dots as well, going across here. And we land on another point that's on the circumference of that same circle with the radius of the square root of 4. Then we're going to draw a line along this line on the Cartesian plane. And we're going to go to this point here, which is defined by this line here, which is the 15-degree line, or a 15-degree line coming off of that vertical line. So we know that the numeral for 4 has that little tail as a part of its design. So we have the length of 1 here. The length of this line is the length of 2. This total length from here to there is the length of 3, and then the complete length of 3 plus 1 is 4. And then this triangle is called the special right angle triangle. It has the angles of 30 degrees, 60 degrees, and 90 degrees. So it's a very foundational geometric pattern within geometry. So the founders of the numerals, or the designers of the numerals, wanted to incorporate this design into their numeral for the number 4. So the length of 4 and that triangle have a lot of a relationship, and all of the geometric patterns that were created to represent the numbers contain a lot of geometric information within their design.